Alright, pre-calc, we're still rolling. We have here the caption of the previous slide. The above technique works for any size square matrix for 2 by 2's only. There's a formula which is preferable and faster. And this might be like, oh, like how is this preferable and faster? But that's only when we look at all of this. When we truly use this formula, we'll see that it's actually easier. So that's what I'm doing in this video. I'm just going to pick apart this whole proof slash conjecture here. So if A equals the matrix A, B, C, D, so if a matrix is a 2 by 2 matrix, then A is invertible, so it has an inverse. If, which means if and only if, AD, going back to here, minus BC, so the product of A and D minus the product of B and C is not equal to 0, and we'll see why in a second. And the inverse of A, so A to the negative 1 means the inverse of A, equals 1 over, and this is what we'll do here, is we'll take this and put it in the denominator. So we have AD minus BC in the denominator, and this is why we can't have AD minus BC be 0, because then we would have a 0 in the denominator, and we know that we can't divide by 0. So that's where that rule comes from. And then this next part's a little tricky. So this will be something you have to just memorize probably. But if we look over at this matrix over here, after we have 1 over the AD minus BC, we'll have to multiply all of that by this matrix. So that's going to be D, negative B, negative C, and A. So we'll take that denominator and we'll multiply them by the same terms, but with some of them we'll flip them, we'll change their order up. But if we can memorize the D, negative B, negative C, A somehow, then once we find the denominator of this, we can find the inverse of the original matrix. So the denominator AD minus BC is called the determinant of the 2 by 2 matrix A. So if possible, we'll find the inverse of each matrix. I will go with this one down here. I'm going to start this one off. So first thing we're going to do is find, or we can do here. We'll rewrite the matrix just so we have an example. So if I have A, B, C, D, and I'm trying to get to positive D, negative B, negative C, and positive A, I'll just have to flip these around. So this is D. I'm going to put this in the D spot. We got negative B right next to it, so this is B, but we're going to change the sign, so we'll have a positive 1. And then negative C, so C will stay in the same spot, we'll just change its sign. And then try to find A, and we'll see that A is a 3. We don't have to change its sign, so it's just positive 3. So there's the matrix we would multiply by. So now let's find the determinant. So we've got a 1 over AD minus BC, and AD minus BC. So we'll take A, 3, times D, 2, minus B, negative 1, times negative 6. So we'll see here, this will be our first example of this, but 3 times 2 is 6, and negative 1 times negative 6 is positive 6. So 6 minus 6 in the denominator here, that equals 0. So we could say that since the denominator is 0, A is not invertible, or B is not invertible. All right, and then I'll let you guys do matrix A on your own. You'll find the determinant of that one, and that'll just be a check for us when we get into class for the next class. Thanks for sticking with me. We'll catch you for 8-4.